Mars floating in deep space as Earth glows faintly in the distance. For all of human history, Earth has been our only home. But across the darkness, another world has always been waiting. A frozen, dusty planet that may one day become the first home of humanity beyond Earth. A giant spacecraft approaching Mars, atmospheric entry beginning above the red planet. Reaching Mars will be one of the most dangerous journeys ever attempted. Astronauts will spend months traveling through deep space, exposed to isolation, equipment failure, on radiation, before attempting a high speed descent through Mars's extremely thin atmosphere. Astronauts stepping from a landed spacecraft onto the Martian surface. The first explorers will not arrive to conquer Mars. They will arrive simply to survive. Outside their suits, the atmosphere is mostly carbon dioxide. The air pressure is dangerously low, and temperatures can fall below minus 100 degrees Celsius. Compact inflatable habitats beside a spacecraft, solar panels unfolding. Their first settlement may resemble a scientific outpost rather than a city. Pressurized habitats, power systems, communication equipment, food supplies, and emergency shelters will need to function continuously, with almost no possibility of immediate rescue. Astronauts operating drilling machines and extracting ice beneath the soil. Water will be the colony's most valuable resource. Deposits of water ice exist beneath parts of the Martian surface. That ice could provide drinking water, oxygen, and hydrogen for rocket fuel, reducing the amount of material that must be transported from Earth. Futuristic oxygen production machinery processing the Martian atmosphere. Even the atmosphere could become useful. NASA's MOXIE experiment demonstrated that oxygen can be extracted from carbon dioxide in the Martian air. Larger machines could someday produce oxygen for astronauts and oxidizer for rockets returning to orbit. Underground Martian habitat tunnels protected beneath layers of soil. Radiation may force much of the colony underground. Mars lacks Earth's thick atmosphere and global magnetic protection, leaving its surface exposed to energetic particles from space. Habitats buried beneath Martian soil could provide natural shielding. Interior greenhouse filled with vegetables, water pipes, and artificial lighting. Inside sealed greenhouses, settlers would attempt to grow food using recycled water, controlled lighting, and carefully treated soil. Every drop of water, breath of air, and piece of waste would become part of a closed survival system. Powerful dust storm engulfing the colony while astronauts secure equipment. Mars will constantly test that system. Dust can cover machinery and solar panels, damage equipment, and transform the landscape during enormous storms. A colony must survive not only dramatic emergencies, but years of slow mechanical wear. Growing settlement with construction robots, landing pads, and multiple habitat domes. Eventually, robots could mine resources, manufacture building materials, and prepare new habitats before settlers arrive. Each mission would expand the outpost, turning a collection of modules into the beginning of a permanent Martian town. Vast futuristic city beneath transparent domes, children and families inside. Later generations may experience Mars differently. With gravity only about 38% of Earth's, people born there could develop bodies adapted to another world. Their culture, identity, and relationship with Earth might become completely unique. Human figure overlooking a glowing Martian city at sunrise, Earth visible as a tiny star. Colonizing Mars would not create a replacement for Earth. It would create something humanity has never possessed before, a second branch of civilization on another planet. The question is no longer whether Mars is hostile. The question is whether human ingenuity can become stronger than the world trying to keep us out. And if it can, the first city on Mars may be remembered as the moment humanity stopped being a one planet species.